Alright, so now that we've at least gotten the concepts of the vectors, we can at least now start solving a few questions to see if we've gotten the concept. We have a good base on everything. So we are going to solve 3 questions in this video tutorial. The first one reads, 2 forces, 60 newtons and 80 newtons respectively, act on a point which is common. The angle between these 2 forces is 40 degrees. Find the magnitude and direction of the resultant force. Yes. So if I was too fast in reading the question, you can pause the video and see what the question looks like. So this is the data in the question. That's the data in the question. 60 Newton force and the 80 Newton force, and this is the angle there. The angle is 40 degrees angle between them. So if it was to be drawn, this would be the 60 Newton force, this the 80 Newton force, and we know that the angle between them is 40 degrees, sorry. And if you remember, we said the resultant force is this hypotenuse of the triangle. So hypotenuse of the triangle would be the resultant force. So to find the resultant force, would need to close it, as I have done. Would close these forces, and using the parallelogram rule, we know that running lines running parallel to each other are equal. So 60 Newton, this will be 60 Newton there, 80 Newtons, and this will be 80 Newtons there. Sorry for the drawing, I'm not very good at drawing, so that's how bad the diagram looks. But basically that's it. That's the information that we have. So if we come to look at this, this is not a right angled triangle, so we would not use Pythagoras theorem to find the longest side, but rather we would apply cosine rule on this one. And for us to apply that cosine rule better, we would have to assign maybe letters or anything to the sides for the angles and everything. So let's name this A, let's say this is B, this is C, and that's D. Then for us to find that line there, we need to identify the value of this angle. How do we do that? We apply basic mathematics for angles. We know that a straight line is equal to 180, and if we have a 40 degrees angle there, we would find this angle by saying 180 minus 40 is equal to the missing angle there. And so 180 minus 40 is, the angle will be 140. And that's what we put there, because a straight line is equal to 180. Remember that. So we have everything. So we can now write the formula for finding the resultant force, which is the hypotenuse. And if this is B, then maybe we can even draw something again, since we just want to find the length of this. So we can cut out of this parallelogram, we can cut out this triangle there and draw it just there in a small way, just a small one, just a small triangle there. And this is 140, this is B, this is C, this is A, and so we want to find that side there. If this is B, then this will be small letter B. If this is C, we'll assign small letter C and small letter A. And the formula is B squared, small letter B, is equal to A squared plus C squared minus 2AC cos B, which is the angle. So we have all our data. This is 60 and this is 80. So we can start solving. So the small b is what we are looking for, is equal to the small a, we have it 60 squared, plus the small c is 80, minus 2 times 60 times 80 cos, the angle is 140. Let me stretch the camera a little bit. Okay, yeah. So if we solve this, to be b squared is equal to what's 60 squared. 60 squared, if you get your calculator and you have it, you get something like 60 squared, you get 3600 plus 80 squared is 6400. So 3600 is 60 squared, 80 squared is 6400 minus 2 times 60 times 40 will give us 9600 cos 140. So if you get to solve this, b squared is equal to, we can solve it. If you have calculators and everything, you can start solving. If we do our mathematics correctly, we solve everything. We first add these two, 3600 plus 6400 to give us 10,000 minus 9006 cos 140 is a negative 0.766, so multiplied by negative 9600 to give us a plus there, 7354.03. then b squared is equal to 10,000 plus that is 17354.03. Then for us to find the final length, we introduce square roots on both sides. This cancels that. Then b is equal to square root of 17,000 is 131.74 newtons. That's the magnitude we've found. So that's this line there, which is this. Okay, then for us to find the direction, which is the angle, we use the formula sine A over A is equal to sine B over B, and this can be vice versa, having the sines down then the thing. So this should be a small letter b there. So we want to find the angle, which is this one now. This one, since the whole thing was 40 degrees, but we want to find this one after cutting it, and that's that one. It won't be half of it. We haven't bisected it, so don't say half. So we use this formula to find, and it's easy because we have almost everything. What's sine A? So the big letter A will be this angle we are finding now. Then the small letter A will be this. Big letter B will be this angle, and the small letter b will be this, and we've found it as the resultant force. So sine A will be sine A, since we don't have, over A, which is 60, is equal to sine B is sine 140 over B, which we have, and it's 131 stroke, or point, sorry, 74. Then we can do our mathematics there. So this multiplied by that, we'll have sine A 131.74 will be equal to, let me stretch this a bit, let me stretch the page a bit, it's small, will be equal to 60 sine 140. Then we do not want this 131 there, so we'll divide both sides by 131.74. Then we'll remain with sine A is equal to, if we do our mathematics right, sine 140 times 60 over 131.74, it will give us 0.2928. Then since we are looking for the angle, we make the angle, which is the subject of the formula, is equal to sine goes that side and becomes sine inverse 0.2928. Thus the angle will be equal to 17.0 degrees. That's how you find it, and you denote your answer as the resultant force is equal to 131.74 newtons at an angle of 17 degrees towards or with the force that we didn't use. If you remember, we were using this force, so we get this force because it is with this force here. So with the 80 Newton force, with the 80 Newton force. So that's how you basically find it.